Hello and welcome back guys to another Alpha Math video. In this lesson, we'll be focusing on the laws of exponents. Okay, our first law is the product law. This law states that when we multiply numbers with the same base, that we can simply add the exponents. For example, say you had 2 to the power of 3 multiplied by 2 to the power of 4. These exponents could be added 3 plus 4, which is equal to 2 to the power of 7. Now, obviously, you can simplify that further, but the main objective here is to look at what's happening to the exponents. 2 to the power of 3 times 2 to the power of 4 became 2 to the power of 7. So the exponents were added. Now let me write another example, but this time using some algebra. So here we have a to the power of 2 times a to the power of 6. When we multiply these two bases, remember to add the exponents, and it's equal to a to the power of 8. Okay, let's simplify this expression. Negative 3 times negative 6 is equal to positive 18, and then x to the power of 1 times x to the power of 2 would be equal to x to the power of 3. You're combining those exponents. 1 and 2 is 3. Okay. Then y to the power of 4 times y to the power of 5, that becomes y to the power of 9. Okay, and this is your final answer. Let's have a look at the next exponent law. Exponent law number 2, the quotient law. The word quotient means to divide. So x to the power of m divided by x to the power of n is equal to x to the power of m minus n. Now let's have a look at our first example. We have 3 to the power of 4 divided by 3. Now remember, the 3 at the bottom is actually 3 to the power of 1. Okay? So the law says when we divide with the same base, we subtract our exponents. And therefore this will become 3 to the power of 4 minus 1, which is simply equal to 3 to the power of 3. Okay, you don't need to simplify this further. I just want to show you what happens with the exponents. This one reads b to the power of 5 divided by b to the power of negative 2. So we're going to take the top exponent, which is b to the power of 5, and then we're going to subtract negative 2, which is the bottom exponent. So 5 minus negative 2 is equal to 7. And therefore your answer is b to the power of 7. And that's it. Okay, I'm going to write down another example that's maybe just slightly more complicated than these. So negative 18 times x to the power of 4 times y to the power of 8, all divided by 2 times x to the power of 3 times y to the power of 4. Okay, again we'll start with the numbers. Let's do negative 18 divided by 2. So I said with the numbers, you're just going to work with them like you usually would. 18 divided by 2 is 9. So your answer is negative 9. Now let's work with the exponents. X to the power of 4 divided by x to the power of 3. We need to minus those exponents, and that leaves us with x to the power of 1. Now you don't need to write the 1 because whenever you raise something to the power of 1, it stays the exact same. So we don't have to write the 1. Okay, but y to the power of 8 divided by y to the power of 4, remember you are minusing your exponents. You're not going to divide the exponents. So that becomes y to the power of 4 because 8 minus 4 is equal to 4. So this is your final answer. Moving on to our third law of exponents. This law, along with all the other exponent laws, describes itself so well in its name. We are taking a power and we're raising it to a second power. Okay, now the law indicates that when we have double powers like this, a power raised to another power, we need to multiply those powers. Okay, so for example, if you had 5 to the power of 3 raised to the power of 4, you simply need to multiply these powers. So it will become 5 to the power of 12, meaning 3 times 4 is 12. So to repeat, when we raise a power to another power, all you need to do is multiply those powers. Right, let's have a look at a few more examples. C to the power of 5 to the power of 2. Again, there's a power raised to another power. Multiply these powers, and that gives you c to the power of 10. Another example might be 4 times x to the power of 2 times y to the power of 7, and all of this being cubed. So what we're going to do is take this outside exponent, the 3, and we're going to raise each of these parts of the term to that same power. So the 4 will be raised to the power of 3, the x squared raised to the power of 3, and the y to the power of 7 also raised to the power of 3. Okay, now we need to simplify. 4 to the power of 3 is 4 times 4 times 4, which is 64. X squared to the power of 3, remember you can simply multiply the exponents, so that becomes x to the power of 6. Then we do the same thing for the y to the power of 7. 7 times 3 is 21, and that's your answer. And now we get to the more interesting laws. The root of a power law states that, let's say you have x to the power of m, and then you are taking the nth root of that x to the power of m. We can then rewrite this as x to the power of m divided by n. So it's this little inside exponent being divided by that outside little number. So we're going to do a few examples, and I'll even show you how you can go from this to that, or sometimes how you can go from that expression to this expression. For our first example, we are dealing with quite large numbers. 7 to the power of 18, and then all of that is under this root 9. Okay, so this is simply going to be 7 to the power of 18 divided by 9, which is equal to 7 to the power of 2, which gives us 49. Let's have a look at a few more examples. Our second example here is x to the power of 6 under the square root. Remember, the square root means that there's an invisible 2 over here. Okay, because square means raising to the power of 2, so square root would be the opposite of that. Okay, so here we're going to say, dividing our exponents, we're going to say 6 divided by 2. So that becomes x to the power of 3. Okay, let's have a look at another one. Example 3, the cube root of negative 8 times a to the power of 12 times b to the power of 15. Okay, again, we want to start with the number. So the cube root of 8 is 2, and therefore the cube root of negative 8 is negative 2. So this is equal to negative 2. Then a to the power of 12, when you find the cube root of that, you are dividing the exponent by 3. So that becomes a to the power of 4. Again, b to the power of 15 means that when we take the cube root, we're dividing the 15 by 3, and that becomes b to the power of 5. This is your final answer. Now, I did also say that I'm going to show you how to convert from these fraction or rational exponents into the third form. Okay, so let's have a look at this first one. We have x to the power of 3 over 4, and how are we going to convert this into its third form? First, remember, it's the inside exponent divided by the outside exponent, meaning 3 should be the inside exponent. That should be x to the power of 3. And then the outside exponent would be part of the root. So that's going to be root 4, and inside the root 4, we'll have x to the power of 3. Same for this other one. 1 would be the inside exponent, 2 would be the outside exponent. Now, the 2 and the 1 could both be invisible, so you could actually just write this as square root y without the 2 and the 1, because when we say square root, we imply the 2, and when we say y, we imply y to the power of 1. So it's just written as that. Moving on to some more examples, and this is probably the easiest law. because this law states that anything raised to the power of 0 is always 1. If you have 4 to the power of 0, that is just equal to 1. Anything to the power of 0 is 1. Even pi is just a number. And when you raise any number to the power of 0, it's always equal to 1. Even if you had variables like 7x, when you raise this to the power of 0, that becomes 1. So anything to the power of 0 becomes 1. But let me throw in a curveball. What if you had 7 times x to the power of 0? Now notice, the 7 is not being raised to the power of 0, it's the x that's raised to the power of 0. So 7 should stay as is, but the x which is being raised to the power of 0, that becomes 1, which means your final answer is just 7. Compare that to this example over here, where 7 and x was both raised to the power of 0. And that's all for the zero exponent law. Moving on to the negative exponent law. This law states that if you have some number raised to the power of a negative exponent, first, find the reciprocal of that number and then change the exponent to positive. Have a look at these two examples. Here we have 3 to the power of negative 4. The reciprocal of 3 is 1/3. Now raise 1/3 to the positive version of that exponent. The positive version of that would be 4. So 1 to the power of 4 is just 1, and 3 to the power of 4 is 81. So this becomes your final answer. If you can figure out what happens in that step, finding the reciprocal and then changing the exponent to positive, then you are A-okay with this exponent law. Right, let's have a look at the next one. 2 over 5 raised to the power of negative 3. So step number 1, let's inverse this number. So it should become 5 over 2. And then change the exponent, negative 3, into a positive exponent. So positive 3. Now, 5 to the power of 3 is 125, and 2 to the power of 3 is 8. So your answer is 125 divided by 8. Okay, let's have a look at maybe 2 more examples, but this time using algebra. So here we have a to the power of negative 2 times b to the power of negative 3. If we were to reciprocal the values a and b, we should get 1 over a and 1 over b. And then raise it to the power of the positive exponent, which would be 2 and 3. This should then simply be 1 over a squared multiplied by 1 over b to the power of 3, which is then simply equal to 1 over a squared and b to the power of 3. Now, if we take a quick look, what happened from here, a to the power of negative 2 being a numerator, to a to the power of positive 2 being a denominator? Even if you look at the next one, b to the power of negative 3 numerator, and then b to the power of positive 3 denominator. You can see that all what happened was it went from the numerator to a denominator. Okay, so it changed its position. Even if we go back to these examples here, you can see that the original 3, which was a numerator, became a denominator. And same thing here, this 2, which was a numerator, became a denominator. And also vice versa, the denominators, which was 5 in this case, became a numerator, 5. The denominator 1 over here became a numerator 1. So we can see that there's another thing at play here. When you're working with negative exponents, the only thing that you need to do is shift the numerators with negative exponents to the denominators and denominators with negative exponents to the numerators. And that's all. If you apply the law like that, then this negative exponent law becomes less complicated and actually quite easy or fun. I want to do a few more examples. Right, so here we have x to the power of negative 2 times y to the power of negative 5 divided by z to the power of negative 1. I'm going to simplify this entire expression in one line. And the way how I do that is I simply move the numerators, the ones that have a negative exponent, I move that to the bottom. So they become the denominators now, but with a positive exponent. And then I also move the denominators, only the ones that have a negative exponent, I move that to the numerator and then change the exponent to positive. And this is your final answer. Like, that's it. Okay, now only the terms with the negative exponents will be shifted around. Okay, the ones with the positive exponents should remain where they are. In other words, I'm going to keep the 4 where it is, but the 2, which has the negative exponent, 2 to the power of negative 1, that is going to move now to the numerator. So that becomes 2 to the power of positive 1. Okay, then a to the power of negative 3 is going to fall here at the bottom. And then the a to the power of 4, because it's already positive, that should stay at the bottom, okay? And then b to the power of 2 is positive, so it stays at the top. B to the power of 1 is also positive, so that stays at the bottom. Okay, now let's just simplify this. Starting with the numbers. 4 times 2 is equal to 8. So this is 8. Now we can do the a's. A to the power of 3 times a to the power of 4. That should become a to the power of 7. But this should actually go at the bottom. A to the power of 7. Okay. And then b to the power of 2 divided by b to the power of 1. That is equal to b to the power of 1 at the top. Okay, and this is then your final answer. Now, I hope you guys enjoyed the video and learned something today. What I would encourage is that you write down each exponent law, at least the name of each one, and then maybe a few examples and create your own examples. You don't have to take down the examples that I did in this video, but your own versions of them. And yeah, that way you cement the work in your minds and you have a better understanding of what it is to deal with exponents. I'll see you guys in the next video. Bye.